Hey everybody, we're going to get started with chapter 2. Now, before we get into things, I would like you to get your textbook out, okay? Pause the video, get your textbook out, and open it up to page 91. I want you to find page 91. So pause the video, get your textbook out, and get to page 91. Do you have your textbook open? You better. All right. That was a joke, by the way. But you should have your textbook out. So we're going to need it because we're going to read one of the problems on page 91. I didn't think you'd want to write it all out, but we need to be looking at it. So example 1. This is a story problem. We're going to be solving equations, writing and solving equations. So example 1, I'm at the top of page 91. It says Steve Fawcett set a 24-hour hot air balloon record of 3,186.6 miles on July 1st, 2002. Suppose a balloonist, I would like to be a balloonist, has traveled 1,239 miles in 10.5 hours. What speed would the balloonist need to average during the remaining 13.5 hours to tie the record? So, what I want you to notice is that it asks what speed. Whatever it is that we have to figure out, that's what our X is. That's what we don't know. So how fast are they going to have to go in order to tie the record? All right, so what do we know? We know that they've already gone 1,239 miles, and they need to get a total distance to tie. What's the record? Total needs to be 3,186.8 miles. Okay, so they've gone 1,239 miles plus we have 13.5 hours times their speed to get to a total of 3,186.8 miles. So that's the setup. Now let's solve it. I'm going to subtract 1,239 from both sides. That's 0, so it goes away. When I do that subtraction, I get 1,947.8. Now I'm going to divide. When I divide this, that gives me 1. Remember, we've talked about lots of different versions of 1? Well, this is a version of 1. That's just 1 right there. And guess what? 1x is just x. So when I do this division, I get 144.3. So the answer, what were we trying to find? We were trying to find the speed. So 144.3 miles per hour. That's cruising. That's really fast. And a hot air balloon? Dang. Okay. Let's try the one right below it. If you see it in the middle of the page on page 91, it says stacked cups are to be placed in a pantry. One cup is 3.25 inches, and each additional cup raises the stack 0.25 inches. How many cups? There's my question. How many cups? So that's my X. How many cups fit between two shelves that are 14 inches apart? Okay, so I'm going to start with 3.25 inches plus I have 0.25 inches times however many cups I'm going to stack. And I get a total of 14 inches. So I'm going to solve this. I'm going to subtract 3.25. That's 0.25x equals 10.25. 10.75, my bad. Now I'm going to divide. That's 1. When I do this division, I get 43. Now, x represents how many additional cups I've stacked. But remember, we have 3.25 from the original first cup. So my actual answer is 44 cups. Okay, let's try example 2. Solving equations. Part A, 5 times y minus 7 equals 25. I'm going to show you 2 ways to do this. The first way is to distribute. So 5 times y is 5y. 5 times 7 means I have minus 35. And now I can solve it from here. So I'm going to add 35 to both sides. $25 and 35 is 60. Now I'm going to divide by 5. And we get y equals 12. Okay, here's the other way you can do it. Since this 5 is being multiplied to the whole thing, I can actually divide by 5. Technically, I'm dividing this whole thing by 5. And I get 5 over 5, which cancels that out. So I'm just left with y minus 7 equals 5. And now all I have to do is add 7. And just like before, I get y equals 12. All right. Part B. Write this down. 3 parentheses 2 minus 3p close parentheses equals 42. I would like you to pause the video and solve this on your own. Pause it. Try it on your own. All right, you should have gotten p equals negative 4. If you didn't get p equals negative 4, go back and try it again. If you're still confused, make sure you ask about example 2 next class time. All right, moving on. Example 3. 6y plus 21 plus 7 equals 4y minus 20 plus 5y. We're going to solve for y. What you need to do first is simplify each side. So on the left, I can combine like terms. Same thing on the right. 4y and 5y gives me 9y. Now, I have y's on both sides. It doesn't matter which y we zero out. So I want you to imagine that I want to make it so that one side of the equal sign has 0 y's. 0 y's. So right now I have 6y, which means if I subtract 6y from both sides, that's going to leave me with 0. So I only have the 28. Now I have 3y minus 20, and then we can solve it from here. Add 20, add 20. 48 equals 3y. Then we're going to divide by 3. 48 divided by 3 gives me 16 equals y. Okay, so that was part A. Part B. 3 parentheses w plus 7 minus 5w equals w plus 12. So same thing as example 2. I want you to pause the video and try this problem on your own. All right, hopefully you did this problem on your own and you were able to get w equals 3. You might have done it differently than I did, and that's okay, but you still should have gotten w equals 3. All right, moving on. Example 4, part A. 3x plus 4x plus 5 equals 7x plus 5. All right, let's first combine like terms. So that gives me 7x plus 5. And once again, I have variables on both sides, so I want to zero one of them out. So I'm going to subtract 7x from both sides, but what ends up happening is that both sides of the x's zero out. So what does that mean? That means I'm left with 5 equals 5. No more x's. That doesn't mean x equals 5. That doesn't mean that x equals 0. What that means is that the answer is all real numbers. Since this is a true statement, it is true that 5 equals 5. That means that we can say x can be all real numbers. And we use this fancy R to represent all real numbers. So what that means is that no matter what number x is, this equation is always going to be true. All right, let's try part B. 8 parentheses y plus 7 equals 6y minus 8 plus 2y. Okay, so first of all, let's simplify. So I'm going to distribute 8y. 8 times 7 gives me 56. What can I do on the right? I can combine like terms. 6y and 2y is 8y. Now the same thing as before. I'm going to subtract 8y from both sides, and we're going to find that all the y's go away. And I'm left with 56 equals negative 8. Now, last time I checked, 56 does not equal negative 8. So that is false, which means that there is no solution. And if you want, you can do a circle with a slash through it. That means no matter what x is, or y, I guess in this case, no matter what y is, this equation will always be false. It will always be false. All right. One last example here. Example 5, part A. Solve and graph. Ooh, solve and graph. Here's what we have. 9x plus 4 is less than 12x minus 11. How is this different? This is an inequality. This is an inequality. So I'm going to subtract 12x from both sides. That side goes away. I'm left with negative 3x plus 4 is less than negative 11. Okay, now what do we have to do? We have to subtract 4 from both sides. Solving inequalities is 99% just like solving equations. So now I have negative 3x is less than negative 15. And now we're going to divide both sides by negative 3. That's 1. So I have 1x. This is a positive 5 because I did a negative divided by a negative. And I have to flip the sign. X is greater than 5. So remember, when you multiply or divide an inequality by a negative number, flip the sign. When you multiply or divide by a negative number, you have to flip the sign. You have to flip the sign. All right, part B. Oh, shoot, we forgot to graph. Solve and graph, not part B. Draw yourself a little number line. Here's 0, 1, 2, 3, 4, 5. X is greater than 5. I do not want to include 5. So I'm going to have an open circle. Just like that. All right, try part B. X plus 8 is greater than or equal to 4x plus 17. Pause the video, try this one on your own, and then check back when you're done. All right, hopefully you were able to work through the problem and end up with x is less than or equal to negative 3. And when you graph it, you're going to have a closed circle at negative 3 and the arrow going to the left. All right, there is no homework problems that you have to do with this lesson. All I wanted you to do was to take good notes, pay close attention, and do the examples throughout. We'll see you for lesson 2.